Welcome back. At this point, your Titanoboa skills are getting outstanding. You're absolutely ready to run the most sophisticated forms of Llama-led liquidation. So the next few units are going to get a little bit advanced. Don't worry, we'll introduce the remaining concepts you need to know in this unit, which we call pure liquidation. All right, for this and the next few units, we got to say goodbye to our Viper with Hat token. Instead, we're going to be working off of this repository written by our good friend Mackett. Mackett's a member of the Curve team, and to the CurvFi liquidation demo repository has uploaded a few great examples of how to perform more advanced liquidations. We'll be covering the simplest for this one to show off how it works, the pure liquidation, and that serves as the basis for the full and partial liquidation for upcoming videos. We'll start it running over here, and you can see here the pure liquidation Python file. Now, if you're a Vim maximalist like myself, you might enjoy working with pure Python files, but don't worry, we're going to be taking all of this and rewriting it within a Jupyter notebook to be able to highlight some of the advantages of Boa. Of course, with Boa, you can play nicely with Jupyter, which means we can actually chart this, and for this video, you'll be able to see better what's going on. Because a lot of things are happening here. You'll notice one of the things you can catch right off the bat, line 39 here, this is working with WBTC. And on the right-hand side, you can see the borrower health is just slowly getting eroded down to nearly zero, at which point a pure liquidation is happening. What is a pure liquidation? What does this all mean? Let's show this off. Let's move to our Jupyter notebook because it's a bit more familiar. So if you notice, this structure of this is pretty similar to all the previous units. So we'll just talk through quickly at a high level what you need to know. You'll probably recognize the reload extension Boa Python. This is necessary for running some of the Viper cell magic from later. And the second cell is a slightly new concept that you might not have noticed before. If you need to work with addresses within Titanoboa and generate them, it's very easy to type boa.env.generate address to deterministically come up with new addresses that you can work with. This is a nice feature of Mackett's scripts. Basically, instead of having everything happening from the EOA address like last time, we're going to be running external liquidations in this case. So there's a user, a borrower that is taking out the loan, a different trader that's manipulating the market or trading the market, whatever you want to call it, and a liquidator that is going to be responsible for performing this hard liquidation on the borrower. It's kind of more realistic to divide these up. We hide some helper functions here to help us with graphing. And this part should look familiar. We're deploying a dummy oracle using the admin address and setting the initial price equal to the Bitcoin price, which is around $65,000 is the time of this shooting. And then we're creating a brand new Llama-led vault, so there's only going to be one loan within this vault from a different borrower. In this case, it's still the admin who holds the keys to this, and in fact, the admin is going ahead and depositing. We made one tweak here with our scripts where we are relying on this load from implementation that we showed off in prior videos. But if you actually look at the vault implementations here, it's using a different concept. It's loading the ABI directly. In this case, this script is relying on several interfaces, JSON, Curve Router, for example. Within our script, we're pulling it from Etherscan. But if you don't have an Etherscan key or don't want to get one, you could try Mackett's script, which is just pulling the ABI without needing things like the 1 second delay to avoid triggering the Etherscan API limits. So the admins deposited $10 million crvUSD, so there's plenty to work with in this vault. And now a borrower has come along and created a loan. So using the Boa env prank to serve as the borrower, it's creating a much safer 30 bands. And you'll see in the next, as the trader goes through and tries to change the price, how safe this actually is. So even though they've max borrowed at the price of 65,000, and they'll be safe from around like 44,000, give or take, to about 64,000. It's still kind of right at the bleeding edge. We know nowadays crypto markets do nothing but dump, dump, dump. So let's bring in the trader to run this dumping, because here's where the script gets interesting in our opinion. So the trader's getting a little bit of crvUSD and WBTC to work with. And what this script here is doing is pretty cool. It's a while loop, so it's running the entire time as long as the health of the borrower is above 0. This is a key concept because liquidations cannot happen while the borrower's health is above 0. If you're borrowing from LLAMMA, you just got to keep an eye on that health number. Don't pay too much attention because health can actually degrade below 0 at many different points within or below these liquidation bands. So what this here is doing is it's looking at the target price for the trades, and it's doing it in reference to P down. In other words, the bottom of the user's range. So essentially, as long as the price is above the bottom of the user's bands, it's going to keep driving the price down. And then once it falls around that P down range, it's going to just keep fluctuating up and down by about 1%. That's what this 100 divided by 99 and 99 divided by 100 using integer division is doing. Then, of course, we fast forward 600 seconds as we saw previously because we need to give the oracle time to catch up. Then it runs this trade directly on the AMM. The entire process looks a bit like this. You can see the price, shown in blue, starts at this higher value as it gets down to the bottom of the user's band range. So we start around 64 and on this log scale around, whatever, 48 or so. And then it just kind of moves up and down, back and forth, allowing trading to happen around this price. And you can see the trades pump, dump, pump, dump, pump, dump, pump, dump. It amounts around $1,000 back and forth, signified by the green. So that's all that's happening here. And in order to do this, the user's health is just very steadily declining. And you'll notice this takes about 150 trades times 600 seconds apiece. In other words, in the worst possible circumstances for this user, they survived quite a long time at this fairly safe n equals 30 bands. But at the end of it, they end up like this. So this is their collateral chart from before. We notice that all the collateral up to the max price has been erased. They're sitting just in this final band. They got a little bit of WBTC left, but everything else has been converted to crvUSD. So along comes a liquidator to run the liquidation. Let's look at the absolute state of the market at this point. They're in what we'd consider an unhealthy user state. And at this point, their state is on the left here, and the debt is on the right. The debt is, at this point, completely dwarfed by the amount that's been converted to collateral. And this is where we're able to run what we call a pure liquidation. Because if this had not had the soft liquidation mechanism, you would see a lot more Bitcoin collateral, and the crvUSD would not be enough to cover it. But in this case, there's enough crvUSD to cover the debt. So because the user is in an unhealthy state, it's entirely possible just to pay off the debt using this and return all the rest to the user. So this is signified here. The user's unhealthy state is a small amount of Bitcoin, mostly $50,000 worth of crvUSD, $49,000 worth of debt. If you look at the delta between this, that is the current Bitcoin price times the amount of Bitcoin, add the crvUSD, there's about $1,700 on the table for whoever runs this liquidation. Because it's in this pure state, because there's no need to convert WBTC, you can just go ahead and run it. All you need to do, this liquidator comes along, calls the liquidate function, calls the user state, which you grabbed from up here. The controller user state function gives the key details of this borrower's loan. It returns 4 values, the first 3 of which are the current amount of collateral, the current amount of collateral that's been converted to stablecoin, and the overall debt. The 4th is the number of bands. So we're just passing the amount of stablecoin, sending it from the liquidator account, only 2 arguments, and a pure liquidation happened. What's cool about this is the liquidator didn't have to have any WBTC, didn't have to have any crvUSD. They were able to run a pure liquidation just with enough Ethereum in their wallet to pay for gas. And their final balance is a little bit of Bitcoin, a little bit of crvUSD, and the value of this is 1,700, the exact same as we saw above. 1,700, 1,700. At this point, the user's loan is gone. If you look at the user state, there's no loan that yet exists, and the user is out of there. Got absolutely nothing. So liquidated user state, nothing, 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 but at least no debt. That's it. That is a pure liquidation. Pretty cool. In the next unit, though, we're going to go through the more complicated case where what if the user is in an unhealthy state, but it's not quite covered by the crvUSD, so you're going to have to convert some of the Bitcoin into crvUSD to run the liquidation. For now, hopefully you're going to be able to run this in the wild and maybe make a little bit of money. Not too bad. Keep your eye out for the next dump, and we hope you stay safe.